How's it going, folks? Rosendo from MLH here. I just wanted to let you know that we have some great workshop content ready for you today. Let us know in the chat when you are in the live stream. I know some of you are probably still getting through the ad break, so I'll let y'all work through that. It looks like we have a ton of people that are starting to join us now. That's wonderful. All right, awesome. I think, without any further ado, I'll go ahead and bring Veronica up here. They're going to be doing a great workshop on Python and also doing some Q&A afterwards. If you have any questions, feel free to drop them in the chat. And be sure to give Veronica a warm welcome. Hi, Veronica.
Hello, everyone. Thank you for joining the session today. We presented this session on Friday, so if you attended that session, probably you may want to stay only for the Q&A bit at the end. If you have questions at any point, though, please feel free to ask them in the chat window. So let me just go ahead with this workshop. It's getting started with Python and Oracle database. I'm a product manager in the Oracle database org, and I'm looking after the Python Oracle DB driver. All right, so let's move on to a short overview of the Python Oracle DB API. Here in this slide on the right-hand side, you will see that Python Oracle DB driver sits in the middle. And it is loaded by Python. It gives an API that you can call. And it connects to the Oracle database for all standard relational and JSON operations, including SODA. I'm not going to talk about that today, but if you want to have a look at the workshops that we have included in the live lab, you can just go on your own pace. You can run those respective workshops. So what do you need to know about the driver? So to make our developers and users' lives easier, in May 2022, we released a new renamed version of the old CX Oracle driver. So maybe you are familiar with this driver if you are connecting to the database, Oracle database. Python Oracle DB is a major upgrade of CX Oracle 8.3, and it enables the direct access to Oracle database through its thin mode. One way to think about the upgrade is that we added a thin mode to CX Oracle and made this mode the default. The database can be on the same machine as Python or remote, allowing connections from platforms that don't have Oracle client libraries installed. It allows an easier deployment and it has a smaller installation footprint. So that means that you have a better use of resources, and by doing this, you have a better performance. Now, because of Thin not needing those client libraries, this lets you play with it on platforms such as Apple Silicon and IoT devices. The driver is still a binary module, which is needed for performance. And Python Oracle DB has now Mac OS binaries, and they run on Intel and M1 and M2 chips. Optionally, you can run everything in thick mode, and when you run your applications in thick mode, you do use those Oracle client libraries. So in that regard, it makes it the same as CX Oracle. In this new version, the runtime choice to use thick mode is not default. So default, you run it in thin mode. You need to make a call to a function to enable the thick mode. I'm going to talk about that one in the next slide. I wanted to underline the fact that not all functionality which is available in thick mode is available in thin mode, but for our team, this is an ongoing project to bring more functionality from thick into thin mode. It presents support for Python 3, namely versions 3.8 to 3.13, and then we continue to support Python's database API v2 specs in both thin and thick modes. That means that it works with frameworks such as and ORMs such as SQL Alchemy, Django, and Pandas. The driver is still open source. It's using GitHub for its repository, so you can just go there and have a look also at especially our sample files. If you're curious about getting, like a quick start into what you need to do in order to call some of those APIs. And then the license got updated to use dual Apache 2 and UPL. Okay, so I was mentioning we made it very simple to install. You simply running this Python -m pip install Oracle DB, And notice that now the name has changed. It's Oracle DB as opposed to CX Oracle as it was before. In terms of size, the total size is about 20 megabytes on macOS for a fully functional driver, and then it's immediately usable in applications, and then it includes dependencies. But you can optionally install those instant client libraries to be able to use the thick mode as traditionally used by CX Oracle. And the package, the basic package is about 240 megabytes on macOS. So this is the extra for the libraries. So definitely, if you use the thin mode, this has a definite advantage. As a note, you must always call this init Oracle client to use thick mode in any platform. And then if you are on macOS, or Windows, and you have installed Oracle client, instant client libraries because your database is on a remote machine, then you have to set the instant client dir to use the path of the instant client libraries. And if you are on Windows, you have a local database installed, then comment out the two Windows lines so that instant client dir remains none. In all other cases, including Linux, with Oracle Instant Client, make sure that Instant Client dir is set to none. In these cases, you must make sure that the Oracle libraries from Instant Client or your Oracle Home are in your system library search path before you start Python. On Linux, the path can be configured with id config or with the LD library path environment variables. Okay, so let me just jump on to introducing Oracle Live Labs. This is a platform to run this hands-on lab. And it's particularly helpful when learning new technologies, allowing you to practice and apply the concepts that you have learned without the risk of damaging your own compute or database instances. So if you use Live Labs, I would suggest just doing a generic search for this Live Lab called or titled Getting Started with Python and Oracle DB. And the tutorial provides also the Python sample files that you could use or reuse as needed. Also notice that the URL on top of the right corner, this is to access the Live Lab. The tutorial is an introduction to using Python with Oracle database, and it contains beginner and advanced material to explore the features of the Python Oracle DB driver for Oracle database. And after you go through some steps of configuring your environment, the sections can be done in any order. So you can choose the content that interests you and your skill level. There are specific labs which can only run in thick mode because that's what we call advanced functionality. It only runs in thick mode. And then one of that is, for example, SODA or scrollable cursors. And there are a few more labs. But for the rest of the labs, you can run them both in thin and thick modes. Okay, so what do you need for this? To run through the Live Lab, you have to have access to a laptop, and then you need to have an Oracle account. If you don't have an Oracle account yet, then in the next slide, I'm providing the steps that you need to perform in order to create an Oracle account. You need to access this URL that is listed on top of the page of the slide. And then creating an Oracle account is free. You need, if you need any help setting up the account, just feel free to ping us in the chat window, and then we will be happy to assist you. And if you have an Oracle account, then use that account to sign in, and you are ready to start the hand-on lab. Okay, so let's do it. What we're gonna do is I'm gonna demo everything for you. So I'm just gonna open up a web browser and navigate to the link above. I'm gonna sign in and show you what we need to do. I'm actually signed in already, so give me 1 second. Let me show you what you will see. Okay, so this is Oracle Live Labs, livelabs.oracle.com. And then you have a search bar over here. So if you just enter the title of this workshop, then you will be presented with this page. And then using your Oracle account, you just sign in. Now I'm already signing in this browser session. So it's just gonna bypass the whole sign in screen. But then you will be able to see your name over here. So now the next thing that you have to do is like you have to click the start button over here. Now this is gonna pop up a window and then it's gonna ask you, how do you wanna run this live lab? Do you wanna run it on your own tenancy? So if you already have an OCI account with Oracle and then you have an instance already ready for you to use, then you can run the live lab on your own tenancy. But alternatively, if you don't, and then if you are a new user and you want to just try it out, we provide this sandbox, which is primarily a tenancy in our OCI space in the cloud, Oracle Cloud Infrastructure space. And if you click on that, you will have to consent to receive emails from Live Labs. And after that, you submit a reservation. Now, because I already ran a reservation, I cannot run a parallel one. But what you will notice over there is like it's going to give you access to a, so the instance is going to be provisioned for you in the back end. And then what you will see is something like this when I click my reservations. So I have these two workshops, hands-on with Python and Oracle database and getting started with Python and Oracle database. And then what you need to do is like you have to click on the launch workshop. And once you click launch workshop, it's gonna open up the instructions. I can show you actually, launch workshop. So you have on the left-hand side the instructions, and then I have them here already. And you also have view login info. So this is, all right. So this is going to give you access to your OCI. So you can click on this button called Launch OCI. And this is just a brief information about your run in this tenancy. And this is the region. It's just automatically allocated for you when you submit the reservation based on availability in one of the regions that we work in. And then it's going to create a username and the password. So what you would need to do is like when you launch OCI, I'm going to click on that button in 1 second. You have to copy the password, the initial password, which is provided to you. This is a default password, but it's going to prompt you to change the password. So click launch OCI, and then this is going to bring you to this, well, it's bypassing the password entry because I already have it open. But you enter the username and the password, and you land into the Oracle Cloud. Now here in Oracle Cloud, if you click on that hamburger menu, you have a bunch of options in the menu. For example, you can create compute instances over here. Yeah, create instance. It's just going to create Linux VM for you, so you can install whatever you need to install over there. But you can also create a database, okay? So if I click here on autonomous data warehouse, actually I want transaction processing. Okay, let's click on that. Transaction processing. Now notice that I have to make sure that I'm operating in the compartment which is assigned to my user. So I have here profile, and it's telling me that I'm LL110405 user. I have to make sure that my compartment is matching that, because otherwise, if I select any other compartment, of course, like if you have like 50 people running live lab in the sandboxes, then each of them will have their own compartment because you don't want to, mix and match your work. So if I click on another user's compartment, you will notice that I don't have access to their databases or their instances or anything like that. So this is how we keep security, actually. So now you'll notice that when you go through the workshop, you have the steps to create an autonomous database. I'm not going to go through that today. So I skipped this step, and the environment setup, well, bits and pieces of the environment setup. This is like a 5-minute step of creating an autonomous database, and I think that it's a great exercise for you to try on your end. It's really giving the password for the admin user, and then specifying what type of database you want to create. Just to give you a quick example. So I select the compartment where I want to create the database, and then I give it a display name, a database name over here, and then I specify what type of database. Is it a data warehouse? Is it transaction processing? Is it JSON or Apex database? And then I use serverless, and then you can choose the database version. Like I strongly advise if you get an allocation in a region where 23 AI is provided or available in the list, because we have 19C and 23 AI, I strongly suggest you pick up 23 AI, because with this one we also implement vector support. So there are scripts that we provide on GitHub for our driver, where we actually connect to a 23 AI, and then we can do similarity search in a vector database. So this is great actually even for further exercises if you plan to use that sandbox for different activities. And then, yeah, really, this is the username that is defaulted to admin, and then you give it a password over here, confirm the password. It's just a few configuration steps over here, and then you hit create autonomous database. It's going to create a database for you. So let me just quickly go back, and it's created this database for me. So Python ADB 110405, again, the same number matching the username and the compartment. And if I click on that URL, then I have a bunch of details about my database, like resource allocation, general information, all that. I also get the network, how do we allow connections to this database. And notice here that is mutual TLS, MTLS. But you can also set access control list. So if you want connections, for example, only from specific IPs, then you can also go and change those params. What I wanted to show over here is that if I click on database connections, I can actually download the wallet. The way we connect to this database from Python, from a Python script, is via credentials using a wallet. So what I did behind the scenes is like I downloaded this wallet and then I gave it a password over here. I can do it again just for the sake of demoing. Okay. So I download the wallet locally in my downloaded folders. And then I'm going to use that wallet moving forward when I do a bit of configuration on my database. So let me go back to the overview, because I wanted to show you, once I have the database set up, all I need to do is like I need to make sure that my scripts are connecting to that database. So a few things over here. This database has a schema which has been already created behind the scenes called Python demo. And the way to see that is like when I log in, this is SQL developer, which is accessible. Let me show you actually how you get there, because I think this is important. I have to go back to my database and database actions, SQL. And it's going to open up SQL developer in the cloud. And by default, it's connecting me as admin. And then I can check what are all the schemas that I have available in this in this database instance. And as I mentioned prior to actually on Friday, we created the database with Python demo schema. So there are a couple of a few tables over here which are used by the scripts, the Python scripts, and data has been populated in those. So if I run a quick select star from Python demo dot departments, I will see the data which populates that table. Similarly, if I run from Python demo.emp, this is an employees table, then I will see I have number of columns, and then these are the rows populating this table. These are really like sample tables with a minimum number of columns, just used to demonstrate the scripts that we provide on GitHub. So let's get started. I downloaded the wallet, and what I need to do now is like I have to make sure that I upload the wallet into this environment that I'm working in. So two more things I wanted to present. So in my environment, I also have something which is called Cloud Shell. So Cloud Shell is a web browser. Let me just start it. So Cloud Shell is a web browser terminal accessible from this Oracle Cloud console and available to all Oracle Cloud infrastructure users. It's free to use, of course, within monthly tenancy limits, and it provides access to a Linux with a pre-authenticated CLI and other useful tools for following Oracle Cloud Infrastructure Service tutorials and labs. Now, the Cloud Shell appears in the console as a persistent frame, and it stays active as you navigate to different parts of the console. It is pre-authenticated with your console credentials. So over here, if I do a pwd, this is my home, and if I do a list, you will see that I already have, if you go through the labs, let me just, before I say that, if you go through the labs, whatever I tell you, like it's already done, it's detailed in these steps of the lab. So lab 1 is about creating the database, lab 2 is about environment setup, and you don't have to go through the installation of Python 3, Python Oracle DB driver, because they are already installed when you provision the instance in the sandbox. But what you need to do, though, is you have to, and also you don't have to add a schema in your Oracle Autonomous Database. This has already been done behind the scenes for you. But there are some bits and pieces in the environment setup where we have to actually specify when I'm connecting to an Oracle database, what is my schema that I'm connecting to? What is the password I'm using for that schema? What is the admin user? What is the password for the admin in case I have to do some admin tasks? And so on and so forth. From here, what I wanted to show you is like I'm only going to use the wallet upload in this Cloud Shell that I mentioned earlier. And this is pretty much my VM used for my work. So I'm going to run all these scripts over here. I'm just going to do something like Python 3. Let me do this. I'll show you some code. Like, for example, this. Oh, sorry. I need to go in samples. So here are all the scripts. But there is also another tool that we have available in the cloud, which is called Code Editor. So this is very similar to the VS Code that probably you are more familiar with. Let's have it loaded over here, and I'm just going to talk about that as well. So Code Editor provides a rich in-console editing environment that enables you to edit code and update services or service workflows and scripts without having to switch between the console and your local development environment. So like I mentioned, this is your VM where you can just install whatever you need to install, all the packages that you are using in your applications, like download all the sample files like I have over here. This is where I downloaded the wallet. So the step that I was mentioning earlier is like I downloaded the wallet from my instance, and now I had to upload that wallet into this VM, in my Cloud Shell VM. And I have behind the scenes some environment variables that I'm using in my connect to the Oracle database. So let me show you. There is a file called dbconfig.py. This is also provided when you download that samples folder or samples zip archive, which has all the scripts that you see over here. And then, by the way, you also have the SQLs, which show you how to create the schema and populate the schema with the data that I showed earlier in SQL Developer. Now, when you open the scripts in Code Editor, so it's classic. You just go open, like in VS Code, right? And then you specify the folder that you want to look at. So I have samples and then tutorials. So I just specify tutorial over here, and then it's going to list all the files which are contained in the respective path. There is a specific script that if you run through the tutorial, you will see you need to configure. So dbconfig.py is using some environment variables. So for example, Python user, let me just quickly copy that. And then I want to show you how it's been initialized. But there is, behind the scenes, there is also this tutorial script that I ran I sourced, and then all these environment variables which I'm using to connect to the database are already pre-configured with the respective values. Just as an example, if I do echo Python user, oh, okay, so I didn't apparently. So let's run that script. Tutorial script, okay. Now let's go back to samples, tutorial. And as we echo. Okay, so it's using Python demo. If you want to see the wallet location, for example, I do. Okay, so it's using this wallets folder that I showed earlier. And that's the wallet that I downloaded from the database instance. All right, so once you have all this done in a dbconfig py file, we can import this dbconfig in one of the scripts. So if I show you, let's say versions.py. Versions.py is just a sample script. It only shows you how you do a connection to an Oracle database. So what I'm doing is I'm importing Oracle DB, which is the driver, Python Oracle DB driver, and I import dbconfig because I have to make use of those variables which get initialized with the environment variables. And then I'm using this method called oracledb.connect, and I'm creating an object .con, named con, which will persist, okay? And then what I'm specifying in order to connect to an Oracle database, I'm specifying an user. So you notice like I'm using dbconfig.user, and then I specify a password, dbconfig.pw, a DSN, and this is the connection string from the database. And maybe that is something that I want to echo over here. So you see how it looks like. DSN. I hope I call it DSN. Let's see. Let's check. dbconfig, DSN ADB. Okay, DSN ADB. So this is the name of the database. Okay, and then I'll show you how it looks like in here. Sorry. If I go to database connections and I scroll down, I have connection strings and the TNS names. I can use any of them. Sometimes you might want to use the connection string, the full connection string. So it's the long description like that. But because I'm using MTLS, then I can use the TNS name. I have the wallet having those names in. All right, so let's go back and see what my versions.py file is doing. So I'm creating this connection to the database, and then I'm displaying two things. I'm displaying the version of the driver. So that's another method called __version__. And then I'm also displaying the database version. So that must come from the database. So I'm using that object, con, and then I say use version method. Now let's run this script over here. By the way, you also have a terminal in the code editor, so you don't have to use your Cloud Shell. It's just, for me, it's easier because I can switch between them too, so I can do my changes in code editor, and then I can just run my scripts over here. If I do Python 3 versions py, it's telling me that I'm using Python Oracle DB version 241. This is an older version, by the way. We are now on, well, not so old. Database version 236024. So that's my 23 AI database that I showed you I created. So that means that I could connect from my py script to an Oracle database, and I can just display, for now, the version. I can also run a query. So let's have a look at this script. This is, again, importing my driver, importing dbconfig for this connection credentials. And then this is a bit different, right? Like I'm creating a cursor over here. So I do call con.cursor, and I create an object called CUR. I'm just going to reuse that object for different operations that I want to send to the database. So in this case, I'm trying to run a query. So I say cursor.execute, and then I specify the select statement. So in this case, I do select star from departments ordered by department number. And what I'm doing over here is like I am fetching all the rows in this object called res. And for each of those rows, I'm just going to display it. Okay, and then I'll go into talking about close in a second. So let's just run this one. Python 3 connect.py. Oh, query, my bad. Okay, so I have those 4 lines. These are my departments: operations, sales, research, accounting. And they should be similar with what I see over here when I run a query in SQL Developer. So I have the 4 lines, yeah? And I access the same from, sorry about that. So I access the same from my Python script. All right, so let's move on to talking about connection pools. So when you run this exercise over here, what I showed you so far is this step in lab 2, test connection to Oracle Autonomous Database. And I was using another script called versions.py, but there is also a connect.py really running through. You can please, when you run this live lab, go ahead and read through the instructions. It's not just instructions, there is also some generic information used for your learning. And this is also the example that I showed earlier where I run query.py. Now we can move on to, oh yeah, I mentioned the cursor close and connection close. It's important that if you open a connection to the database, or even if you do a cursor, if you open a cursor, you close the cursor because you want to make sure that you don't have a waste of resources. What I wanted to underline is like when you close the cursor, if you want to send new statements to the database, such as like queries or inserts, deletes, any DML operations, you have to reopen the cursor if it's already closed. Similarly, if you close the database connection and then you wanna issue a statement like this, it's not gonna work. So what you need to do is like you have to reopen the connection altogether. Again, this is used just to make sure that resources don't get wasted. Okay, so let's move on to the next lab. The next lab is connection pools, and I also wanted to show you over here, when you run the live lab, you will see there is a short demo. It's a video material. This one is like a 1 minute and 11 seconds. If you run into any issues while you walk through this lab, you can always, just play the video, and then it's just going to walk you step by step into what you need to do, and then it's going to show you what you need to see on your screen. As you walk through the live lab, you can, from the beginning, just expand all tasks. And in this case, I would also suggest you get more information by clicking. So in the introduction section for each of the labs, I mentioned that they can be run in any specific, in any particular desired, order. They are not linked to each other. They just cover different topics. And in the introduction section for each, there will be like a reading link, which is tied to mostly our documentation for the driver. So if you want to know more about connection pooling, then you just click this URL and it's going to open up the documentation. Our documentation, by the way, is Python Oracle DB read the docs.io. And then it's also split into all these sections, like what you need to do, for example, to install the driver, to initialize the driver, just have a look at this. Right. So I mentioned connection pools. I just wanted to give you a, let's say, short intro into connection pools, like why are they important? So the we do two types of connections to the Oracle database. Standalone connection, which is what I just showed you earlier, where you have like a one connection to the database, you run a series of operations, and then you close the connection. But there is also the concept of connection pools, where you can actually have parallel threads running at the same time. So you can open, let's say, like 20 connections. And then the way to do that, I'm just going to show you the techniques on what you need to do when you create a connection to specify it's a connection pool. So let's have a look at this example. I create a pool, okay? And this is the method that I have to use to create a pool, oracledb.createPool. And of course, I just save everything into this object for the pool. And then I use the same credentials that I use to connect to the database. So I have my user, password, DSN, configuration directory, wallet, and all that. Yeah, wallet location, wallet password. But I also have min, max, increment. Okay, so let me just walk through those things. A min, in this case, we have a min of 2, specifies the minimum number of connections that the pool will maintain. So even if there is low demand, a minimum of 2 connections will be kept open. And max defines a maximum number of connections the pool will allow. And in this case, it can open up to 5 connections, but no more than that. There is also this parameter called increment. So increment indicates the number of additional connections to open when all connections are in use and more are requested. So if I have an increment of 1, that means that I will just increment by 1 connection. Also, you will see that a practice is to have min and max equal each other. So for example, I can have min equals 20, max equals 20, and increment equals 0. So what does it mean? When an increment is 0, no additional connections will be created beyond the initial pool size. So the pool is always maintaining exactly 20 connections, and no allowance for dynamic scaling is based on demand. Okay. Just a few words on why connection pool is important. This is, of course, performance increase when multi-threaded applications frequently connect and disconnect from the database. And pooling also gives the best support for Oracle's high availability features. So use a pool if you have a lot of connections that will be used for short periods of time, and a small number of connections that are idle for long periods of time. Pool advantages being that you have a reduced cost for setting up and tearing down the connections, and also it's good for dead connection detection. Now, once acquired from a pool, a connection behaves the same as if it was created as a standalone connection, and can use external authentication to avoid hard coding of credentials. And then it has this with clause, which ensures that the connection is closed once the block has completed. So again, like the standalone connection, you can just explicitly issue a connection.close. Yeah. If you don't issue that connection.close, then it will be closed automatically when connection goes out of scope. Here is like, go ahead and read. This is pretty much what I was explaining. So let's go and run some queries. I'm just going to show you this connect pool.py. Let's copy this. Oh, give me 1 second. This pops by here. Connect pool py. So you see, I have actually 2 threads. Let me just walk you through that. Connect pool py. So what is this script doing? First of all, I have a new import over here, which is called threading. This is a module for creating and managing threads. And as I specified, I create a pool, and I have this object called pool because I'm going to use that object further down. And this is just my connection to the database using the wallet. and the credentials for that. I'm specifying a min of 2 connections and then a max of 5 with an increment of 1. And there is also this variable called get mode, which has this method called pull get mode wait. This is actually something which is telling the connection pool that it has to wait if no connection is available. So the threads will wait until one becomes available. So I also have an object called query. And this is called by each thread that I'm creating. And then I have this threading.thread, right? Threading.thread, which creates 2 separate threads. So I have thread 1 and thread 2, each of which will run the query function concurrently. Query sets the function to be executed by each thread. So in this case, the query function. And thread 1 start and thread 2 start starts both threads, which will run in the query function, which will run the query function concurrently. I also have this, thread join. Join ensures that the main program waits for both thread 1 and thread 2 to finish executing before continuing. So in my case, I say for I in range 4, so I have 4 instantiations of that thread. So I run the thread 4 times, and I have, so they run in parallel. I have 2 connection pools. So like 1 connection pool for thread 1 and another connection pool for thread 2. All right, so let's go back to the workshop. There are more experiments, like we provide more scripts. This connect pool 2.py is giving you, let's see what this is doing actually. Let's run it. Okay, so it ran each thread. Let's open it up 10 times. All right, now let's move on to the next lab, so fetching data. Fetching data. Executing select queries is the primary way to get data from Oracle database, okay? And to get data out of an Oracle database is run in different ways. So first of all, you can parse the statement for execution, then you can just like bind the data values, execute the statement, and fetch the results from the database. We have something which is called query2py. I'm going to go ahead and run this query, but let me just walk you through it first. So again, I'm importing the driver, importing the dbconfig for the credentials. I create a connection to the database, and I keep it in this object called con. Now what I'm doing is I'm creating a cursor, and then again, I'm selecting star from department order by department number. So my execute statement is this select. And then notice that over here, for each column in the cursor, I'm going to go ahead and print department number, and then department name and department location. All right. So let's go ahead and run this query. And instead of seeing like each row, like in the query before, now I'm just going to display the values contained in each column for each row. Okay, so 10, 20, 30, 40, but then I just expand them into department number, department name, department location. All right. Now let's talk a bit about fetching the data. When you fetch the data, you can fetch all rows, you can fetch one row, or you can have fetch multiple rows. So first script that I have over here is going to talk about fetch one. So this is using this method called fetch one. again, creating a connection, opening up a cursor, executing a statement in the database, and then now I initialize this row variable with cursor.fetch1. Fetch1 is just going to fetch one row, and it's going to display that row. And then I can go ahead, and then I'm going to fetch another row, and then I'm going to display it. So let's go and see how this works. So let me just go and copy the query1.py. I have both rows displayed over there because I think that in my script, I have not commented this line. But if you want to see that only one line is being fetched, what you do is like comment those two lines, and then you rerun the script. And now I only get the first row in my database. Similarly, you can, get each line if you print them one by one. Yeah, all four of them. So this is showing you how we can fetch only one row from the database using cursors and fetch one method. You can also fetch data using fetch many. So similarly, creating a connection to the database, opening up a cursor, issue an execute statement on that cursor, and then I'm going to say, hey, I want to retrieve 3 rows. I know I have 4 rows in the database, but I want to retrieve only 3. This is really like for the sake of exercising. And then what I'm doing is like when I'm calling the fetch many, I'm specifying the number of rows that I want to fetch. So let's go ahead and run this query. So query many.py. All of these are available in your sample when you go and download the sample. You can also download it on your local machine and then use it as a quick start if you want to build applications connecting to an Oracle database. Okay, so this is what my results are using fetch many. So I only got 3 rows, right? 1, 2, 3. And of course, this one is like a first row. So I'm displaying more information here. If you only want to display the first row, you just call res of 0. And then if you want to display the second element of the first row, you do res 0, 1. Okay, because it's the element in the list. All right, let's move on to the next module, which is tuning with array size and prefetch rows. Now, I mentioned that the fetch many method returns a list of tuples, and by default, the number of rows returned is specified by the cursor attribute array size. And array size, it's attribute which is defaulted to 100, of course, for performance reasons. And what does it do? Array size attribute determines how many rows the cursor will attempt to retrieve in a single fetch operation. So by adjusting this value, you can optimize performance when retrieving large result sets. Of course, increasing the array size can significantly reduce the number of round trips to the database when fetching large amounts of data, which can then enhance performance. If you have the memory considerations in mind, setting array size too high may lead to increased memory usage, so it's important to balance the number of rows fetched with available system resources. As a default behavior, you can always reset array size to its default value, which is 100, if you find that a specific value does not work well for your use case. And in this example, I wanted to tell you that we created also, again, behind the scenes, using those SQL scripts that are in the sample files, a table which is called big tab, TAB, which only has one column of array, strings, and it has 20,000 lines. So why is this important? Because when we want to try to fetch the data from this table, we are going to use that array size to show you how many rows you can fetch in a cursor. And what results do you get in terms of times elapsed until you get the results, depending on different array sizes that you use. So again, it's 20,000 lines in this table, and I can quickly go and show you. Big tab. This is how they look like, but it's not important what the values are. What is important here is like the number of rows. $20,000. Okay, so now let's go back to the script. So let me just open that script. So query array size py. You see that we set the prefetch rows to 100 and the array size to 100. And then I'm going to fetch all the records from that respective table. So I'm using the cursor to run the select statement. That's the query statement, and then I'm using rest to hold the fetch all. So all the rows are supposed to be there. And I mentioned that we are doing time calculation. So I'm importing this package called time, and I'm going to use the time when execution finished minus the whatever time it was when I started the execution, and then I'm going to print the elapsed number of seconds for that operation. So query array size, let's go ahead and run it. Query array size. Let me also open it over here so you can see it. Query array size. And let's see. I ran it on Friday, and then on Friday I put those values really high. So let's do 100 and 100. And let's rerun it. You will notice it's going to take a while. It's 20,000 rows, and I'm only fetching 100 at a time. Okay. It takes 23 seconds on average, 23.6 seconds on average. Now, watch out what's happening when I'm increasing the array size to 1,000. So still not a larger number, but still more than 100. So let's check that out. 2 seconds. Okay. Now, watch what's happening when I put here 10,000. 0.9. Also, there is a rule of thumb because each of these batches, let's call them, of rows according to the array size, will require a trip to the database. We advise that when you use array size, let's say 20,000. I know I have 20,000 rows over here and I use 20,000. When you do a prefetch rows, you also want to make sure that these prefetch rows equals the number of array size plus 1. Why? Because otherwise, array size doesn't know if there is anything in the buffer. So it's going to do an extra round trip to the database. So in order to avoid that, you just do the prefetch rows increment 1. So then another database trip is not necessary. All right, so I think I only have time for one more workshop, and I maybe want to go walk you through the binding data. Again, have a look at the workshops that are presented over here. Like we do lots of stuff around PL SQL, LOBS. This is tick mode. I actually wanted to have a chance to show you how you run a program in tick mode as well. But maybe I'm going to keep 1 minute and get through that one. Sorry about that. Oops, I keep hitting this. Let's go to binding data. So data binding, this is a feature that allows the database, well, let's go walk through the tasks. I'm keeping in mind that I only have 5 minutes, so I don't know how to run this. So let's do bind queries. What are bind queries? Bind variables enable you to re-execute statements with new data values without the overhead of reparsing the statement. So for example, if you want to use select star from departments where department equals A, and then you want to run select star from departments where department equals B, if you don't want to just reuse the same statement, what you do is like use these bind variables. And let me show you how that looks like. Select star from department where department number equals, and then you put these bind variables. And then when you execute the statement, so that is on the prepare statement. And then when you execute the statement, what you do is like you pass the respective ID. So that value 20 is going to be passed to this statement first time you run it, and then secondly, when I run a second execute with the ID 10, then 10 is going to replace my ID variable. Okay. Other than that, just remember that you use bind variables in the prepare statement, and in the execution, you just initialize those with a value. Let's go ahead and do a copy of that script so we can run it and see how the results look like. And if I show you the script, also what I'm doing is I'm using this statement cache size. I don't think I have time to talk about cache size, but this is an attribute that manages the size of the statement cache for a database connection, and the statement cache size is configurable for each connection. Again, like I'm fetching all rows in here, as you see, but because I only have one row with ID of 10 and only one row with ID of 20, then of course I only get those rows over there. Okay, I still have like 3 minutes left for questions. So if there is anything in the chat window, or if there is anything that you want to ask me, please go ahead and put your question in the chat. We also have some colleagues which are helping with the questions. But other than that, thank you very much for joining this, and let's keep the next 3 minutes for Q&A. Are there any questions? Rosenda, can you help me with that?
Hi, Veronica. It doesn't look like there are any questions in chat at the moment.
Okay.
If that's the case, yeah, we could probably wrap it up here, unless you have anything else you want to walk through.
No, I would highly suggest that have a look at the autonomous database. Use our live labs, use our live sandboxes, and feel free to hit us up with questions. I can actually eventually give me 1 second. I'm thinking maybe I put my email over there. So if anybody has any questions, feel free to email me. Yeah, this is my email.
Awesome. Well, there you have it, folks. Veronica, thanks so much for joining. Really appreciate it. Great workshop, very informative. Basically walked you through all of the challenges that you could participate in at Global Hack Week Open Source. If you're looking for the link for that, it's up on the screen here. Make sure you participate. There's going to be some great swag being offered as far as like stickers and postcards are concerned. We're also doing a raffle for anyone that does complete some of the challenges. That's going to be random and selected during our closing ceremony. So definitely pay attention to that. But outside of that, once again, thank you so much, Veronica. And we really appreciate everyone that joined us for the workshop here today.
Thank you
We'll
very
see you.
much.
Yeah, of course. We'll see you again next time. Have a good day.
Cheers. Enjoy. Bye.